Hi everyone, this is a GMAT 700 level problem solving practice question. This question is from number properties, concept tested, divisors, properties of remainders and application of the Euclid's division algorithm. Good question, it will teach us quite a bit about divisors, remainders and how they work. A number when divided by a divisor leaves a remainder of 24. Good. When twice the original number is divided by the same divisor, the remainder is just 11. What is the value of the divisor is what this question is. Let's set this division in the form of a Euclid's division process, right. Let's say a number is n, it is divided by a divisor d and the remainder that we get is equal to a 24. That's what the first sentence says. A number when divided by a divisor leaves a remainder which is 24. Any division will have a number, a divisor, and then you're going to have a quotient and a remainder. The quotient is not mentioned, so I'm going to assign q to be the quotient. By Euclid's division algorithm, we can say this number n is equal to the divisor times the quotient qd, or the quotient times the divisor, plus the remainder is what we have. So, establish this number n in terms of the divisor, remainder and a quotient that we have assigned which is equal to a q. Second part says when twice the original number is divided by the same divisor. This is n, 2 times n is going to be 2 times right hand side, which is 2qd plus 48. When twice this number is divided by the same divisor, the divisor remains unchanged. The remainder for this division is equal to 11 is what they are saying. Let's divide this right hand side also by a d. So, this is going to leave us with some quotient and we have a remainder which is equal to 11 is what they are saying. Let's just focus on this part alone. 2qd plus 48 is divided by the divisor to leave us with a remainder which is equal to 11. Look at this part, right? It's like sum of two numbers divided by a divisor. So, we can find out the remainder for each division, add those two to arrive at the final remainder. So, 2qd when divided by d, d will get cancelled with d, which essentially means that 2qd is divisible by d, right. If 2qd is divisible by d, for example, if 8 is divisible by 4, then essentially we are going to have a remainder which is equal to a 0. So, because 2qd is divisible by d, this component 2qd by d, the remainder for this division is equal to a 0. So, this remainder 11 that we have got, therefore, should have come basically by the division of 48 by d. We have broken the numerator into two parts. We are finding out the remainder for each part. The sum of both those remainders should have given us the final remainder which is equal to 11. So, this part leaves us with a remainder of 0. So, 48 by d, the second component, is what should have given us a remainder which is equal to 11. What number when it divides 48 will leave us with a remainder of 11? The divisor has to be a 37. 48 divided by 37, you will get a remainder, a quotient which is 1 and a remainder which is equal to 11. Let's take a look at the answer options, see whether 37 is one of the answer options. Yes, 37 is one of the answer options. So, choice D is the correct answer to this question.